Morning, sir.
Morning. Sorry, my mic was muted. We are going to move over what we did yesterday. But I see people who were here yesterday are not here. Right, I see we have got new people here who were not here yesterday. Right, here I'm here to give you work. And the most important thing that I need you to be aware of is I'm going to be paying for productivity on this work, especially those that are new. Those that are already here always get incentives. What I'm giving you now is part of documentation that is needed for Bluetooth. Just give me 1 minute. I'll just come and start after 1 minute. Maybe we can have one more people. All right, let's start. I'll just show you what we did yesterday. Okay. All right, this is what we did yesterday. This is what we did yesterday. Okay. When you are given a function like this one here, pub key hash address, this down here, we try to make it a little bit clear here. So when I was looking at the examples that you did, I've given out some comments. I think we should make it a little bit more clear. You can look here, for example, this is a redo. There are too many lines, too many blank spaces. I think it will end up confusing people with too many lines, too many blank spaces. Let me just see how we can simplify this. Oh, that thing closed. There. We need to simplify this. Keep what is important. Function name is important. This one is okay. But you see here, there is a blank space here. I think it makes it right. I think here, let's just say in for input, here out for output. Or yeah, output. Output is okay. And then here, I think let's just take out this, say this column here. Let me first take out this two, because we are not using them now. Let's see how this, maybe it can look better. Yeah, then the code here. Then take out these columns. Let's see how it is. So here is of a type. I think it's okay. But I think this one now needs to be one column. For example, let's make it yellow. And then push it to the left, equals. So input this equals confuses people. Let's take out equals. Take out this column. Let's just take out this. Right here, this is where we can say equal. We have the word equal. Let's see how it will look like. Right, I've taken out a lot of stuff. Let's see if it helps or it makes it worse. Right, so I've got a function pub key address. Takes in pub key hash returns. I think we can put return here. Return in, or we can say arguments. In, out. Out is okay. In, out, in, pub key hash, out this. This is type signature. In this code now, but remember here we are repeating this. Let's put the equals here, see how it looks like. I just want to simplify this for new people. Let's test it with those that are new. This is, you repeat this, we do that. And then this one, Right, we are going to test it with all those that are new today. Okay. Before we do that, let me save number one. All right, what we are missing here are the actual arguments. So we need one more column here. For example, pub key hash is pub key hash. We need it. All right, let's try to rearrange this. Let's try to rearrange this in out here. And then we have that pub key address. Shows here. Copy that here. And then here under out, we're still going to have this out. Then we take this one here. Let's have another row here. Because this is an input. This is an output. This one is okay. So for the inputs, you need to have variables. Right, in this case, pub key hash is PAH. Let's see if it makes it easy now. Let me take out this row. All right, let's test it. Let's see if this makes sense. We can leave out this one. Yeah. That's a variable. Here, let's say input, output, instead of saying it's all right, it is input. So that we explain this one, let's say this is the processing. Or let's call it logic, function logic. I don't know which one is easy to understand. Right, this and this and this. We can leave out this. I think this one is not important. We can leave it out. We can make this one that color. And we can combine this one. Now the logic needs a complete different color. This this one. Okay, right. We have simplified this. Let me get all new people who have not seen this before. I think all of you can have access to this part here. You can see. Am I sharing my screen? Can you all see my screen here?
Yes, sir.
Right. Here, the most important thing is inputs. You can have more than one input. And then there are variables that are going to be used in the logic. Now, I'm going to give examples from things that you know. Then we see Let me see how many new people are here. Right. Loco. I think Manasseh is also new. You give us your feedback. What we are doing here, we are simplifying the Haskell structure. We are simplifying the Haskell structure. We want a person first to have a picture of what is really happening, especially people who are completely new in programming. Right. A function takes inputs, processes, then spits out output. So from the input, you process output. That is the flow we want to show here. We have a function name, call it a machine. This is the name of a machine. We are going to give the machine some inputs. Then it's going to process. Then it's going to give you the output. So the output could come under processing, because the most important part is the processing. So maybe we can even simplify it further. Let's see. We can take out this, we put it here, return, we put it as a return, or as output. What will be the output? Output is going to be address. Okay. This is the processing. It makes sense if we say processing. This is the processing. Then we take out this. Input this. Then we go to processing. This is where to the processing. This equal sign, we need it because we are using this PK here. The inputs must be equal to the output. Let me see if it makes it clear. I'm going to delete things that we are not using. Like, for example, this one here, we are going to make it that color. We are not going to use this. That part is not used. This part here is not used. Yes, the most important thing, the inputs, we will list them going down, and they are variables. Then from the variables, depending on the inputs, we construct the processing. This is the processing. Okay, and then the output. What color will the output be? Can be green. It can be yellow. Why should it be yellow? I think the output, we can give it a different color altogether. Let me give it this color. The output. more pronounced now. Plot. Let me change it to 8. Okay, I'm going to give you an example using this. Let's see if it is easier for new people to understand it. I'm going to give you a new function called volume. We all know calculating volume of a let's say volume of a three-dimensional container with length, width, and height. So using this to construct a Haskell function, what are you going to need? The name of the function. Let's call it calculate volume. Then the next thing that comes into play are the inputs. Okay. And then now let's have the inputs. Following that logic, name, volume, calculate volume. What are the inputs? We have got int first, which is length, another int, which is width, another int. You see now? Do you see now? This makes sense for me. Volume, we've got inputs, int, length, width, height. This is where now when we write the variables, what is this int? Is the length. What is this one? This is the width. And that one, this is the height of a container. So this, to me, constructing a function in Haskell, following this one, is easy. Okay. Volume, it's got this input, it's got these variables. It's got 1, 2, 3. Now let's go to the next step, which is what? We can merge this and say equals what? Equals what processing? Right, we follow this. The processing. I said let's do the processing. Should we really write processing? Yes. For new people, they need to know processing comes here. Then how is the processing like? So now you see, because we have got length, width, height, this is equal to length star width star height. Length is small. This makes sense for me. But this is the processing. What is the output? So we can put the output here in the center. What output are we going to get from here? Int. I think this makes sense. I don't know. Let me hear from you guys that are new. If I can add these steps here. This will be number 1, the name of the volume. This one, then this will be number 2, the parameters. And this will be number 3. Look, we have got this in here. Yes, we can put number 3 equals there. Number 4, step. Do create your processing steps or your logic. Processing or logic. Why I say logic? Logic is the correct word, but processing is also the correct word. Processing logic times this like this. Then the output is number 5. So this is how we can go about creating a what? A Haskell function. I think this makes sense. Okay, now let's get another example. Let's use what we have above, number 1, the name of the function. Number 2, this, you create the name. This one, you don't change this. It must always be logic process. Another way, even if we leave this out, this immediately shows us, okay, we take this, then you process your logic. But it's okay, makes this clear. This is the logic. Output int. Output int. So whatever, when we multiply here, we'll get an integer. That one is important. Okay, let me give another example. Following this one, inputs, check out that. Let's call this number 2. Let's call this number 3. I'm going to give another example of creating a Haskell function. Now let's create a Haskell function that is complicated together. Let's create a Haskell function that solves a real problem that in real life. I'm going to select, let's have real scenarios in our life before we come to the Bluetooth part. I want to follow those 3 steps to construct a function in Haskell. But first, we need to have a problem that we need to solve. You know your physics, I don't know. How do you calculate? Okay, let's take a speed. Calculate the speed of a car traveling from point A to point B. We all know when you need to calculate the speed of a car is distance, then you need time to calculate the speed. So you know what is your processing. Your processing is for speed is distance multiplied by time. See, this one is very easy. If we are to follow this one is very easy. We are going to say number 1, we give the function a name, a vehicle speed, v speed. This is the name of the function. What is the inputs? You see the inputs are 2. Do you see why I'm not writing distance? I'm not writing time. I'm writing int because the inputs here must be the data type. What is distance? It's a number. What is time? It's a number. In Haskell, int is the number. Int is the number. Now this side, now this is where this type, we give it the actual variable. The first one is the distance. The second one is the time. Okay. Inputs, int, correct. Distance is the int. Time is the integer. That one is fine. Then here we have our equal. Now down here we come to the logic. Actually the logic, now the processing follows naturally here, equals distance times time. I didn't say int times int. Why? Because you need the variables here. Okay, so you need the variables. What are the variables? Distance times time. Distance star time. And then what is the output? What am I going to get? You are not going to get distance times time, kilometers per hour. No, you are going to get a data type int. The answer is going to be a number. See, int, output int. This is the number 2. This is the number 3. This is the logic. Okay, I think logic is far. Processing is the better word. This is the output. Okay, I think I managed to create this one here. Now, let's look for a very complicated maths problem together. First, before we do that together, let me ask all those that are new, is this easy to follow? Inezi, Johannes, Manasseh, and Muloko. Are you able to follow those 3 steps to create a function in Haskell? Give it a name, give it inputs, and then you give it variables, and then you do your calculation. Then your output. Output will always be easy, just it's one line. Let me hear what you think. How do you find it? Or you're still confused? Loco, can you hear me? Manasseh, can you hear me? There's no communication. Yes, Manasseh?
Yes, sir. But for now, that's still confusion.
You're still confused.
Yeah.
All right, Lumez, isn't it? I don't know how you pronounce that. Loco, I did not follow because my network was so bad. All right, I'll try again. Muloko, Ramalepe, Loco. I think there's no communication there. All right, let me get feedback from the rest via Rito Prefina.
Okay, sir.
Yeah,
It's very much simplified. Although
yes,
I had a question to ask, but I don't know whether I can ask it. But maybe when we
yes.
have maybe
If you see a problem, remember what we are trying to do here, we are engineering simple ways of approaching Haskell. So that when you come across, remember, like for example, let's look at the actual Haskell functions. Here. Right, here is a Haskell function. But it followed those 3 things. What you see here followed those 3 things. So let me take this one here. We plug it into the 3 things that we have here. Let me just show it here so that I hope it will fit here. But don't worry if you can't see it, but I'll follow those 3. Let's say number 1. What is the name of the function here? The name of the function here. I'm taking this one for now. Name of the function is this one. So it comes here. Then we come to the inputs. How many inputs does this have? All right, let me paste it here. I lost it. Where is it? So that you can see it easily. Maybe I can make it bigger. I think all of you can see it easily. This is the name of the function.
Yes, sir.
How many inputs do we have? If you are confused, start with the output. Output is
input.
always the last after this. If this is not there, like this, you see double colon and you've got this, you know that is the output. You know that is the output. So the only way to identify output on the Bluetooth functions is you look at this last arrow. Like here, you see this arrow, the output is this. Output, output. So in this case, let's start with this one here. Otherwise, you won't be able to work with what I'm going to give you if you cannot identify the output. If you can identify the output like this one, I cut it out because I'm going to put it here under output. So I've got one input, then I'm going to have my equal there, and I'm going to have the processing there. Preferably the output is going to be here. You can put it even here. You will move it there. This is the output. Right, once you have picked out your output, then you pick in your input. You see, I've already done this. Arrow is left in the air. Then I go to the input. I put that input here. Now, whatever you put here, it doesn't matter. It is you who decides what variable name you give to this. This is the currency symbol. It's a type. So you just follow this here. If we come here, you will see they gave it H. They gave it H. So in your case, the variable is this one. On the left side of the equal, that is the variable. Now, what is going to confuse you is now there is a bracket. Now, the currency symbol is repeated. That is the structuring. A currency symbol has one field because you have one H. That H represents a field in the currency field data structure. You will see it when we get to data structures today. But for now, all what you need to know is it is not H, it is bracket currency symbol H. But it is this H we are going to use on the processing. Let's put our equal here. Same way you see it. Where is this one? Here. Same way you see here. You see you've got that equal there. And now, here is our processing. On the other side of equal is the logic, is the processing. So you copy all of it. And then where do we put it? We put it here. Okay, let me first press enter. Yeah, that is the processing. So here now I can say processing. And you know my inputs. And delete this space here. So you see my number 2 is the processing, number 3 is the output. What is the input? It's currency symbol. How is the currency symbol used? Now, this makes it clear because you need to use this currency symbol in your processing, just like you need to use this int in this, use this int here. But when it comes to the processing, this is what I want you to see. The processing makes use of the variable h, which is this one. This h is a field of this. So you say h. So how is this processing? We used another function. We used another function called monetary policy hash. Monetary policy hash is a function which takes a field of currency symbol and produces the output, which is this one, monetary policy hash. This is the output. At the moment, what might be confusing you are looking at new terms that you have never met across. I want you to understand one thing. The output is a data type like string, like int, like bool. This is a Bluetooth data type. Okay, currency symbol is a data type. How do you know? They start with capital letters. Now, here is a problem. So if data type starts with capital letters, but how come this function starts with capital letters? That is strange. So let's go up to monetary policy hash. That is strange because it must start with a small letter. Then we need to go to Haddock for the Bluetooth and actually search search for this monetary policy hash. Am I not getting it here? Okay, let me then search for it straight. Let's search for it. You can search for it under getting validated monetary policy hash. Let's try ChatGPT. Use ChatGPT to understand your processing. Let's say H. Let it figure out. You might give it the whole function. But my ChatGPT is very clever. I don't know why it really figures out exactly. If you follow what you see here, it is saying in the newer Plutus version, monetary policy hash has been replaced by unified under minting policy hash. Older version that. New type monetary policy hash byte string. All right, let me copy that sentence, that function, all of it. Let's give it to ChatGPT. ChatGPT went further to do this. Yes, 10 byte string. 10 byte string, accessing the underlying. Explain this form. But here they are explaining this. Currency symbol is a wrapper around byte string. So this extracts the underlying byte string in H from the currency symbol. Right. The next thing here is, this is what we want explanation. We rewrap the extracted byte string in a monetary policy hash. In Plutus, currency symbol is typically created from monetary policy hash like this. Get monetary policy hash, MP hash. I don't know if it is easy for you, but it is not a function. They say it is a wrapper that wraps this byte string into monetary policy hash, because the output must be monetary policy hash. Well, this is a function where the output, the processing part, is a wrapper. It's not a function. Back to what I said. A function will always start with a small letter. A type will start with a capital letter. All right. For now, let's leave it like this. So basically, all what I wanted was you to be able to do this. That's what I want you to be able to do. Where we can distinguish clearly the name of the function to processing the output. For the processing to take place, you need the inputs, but you don't use the types directly here. You need to have a variable of it. Right, let me go to the next function. Right, I think these functions are too simple, very simple. This is the input, it will go under inputs. And then here, where is the variable name for the text? They didn't put it. See, this is what is going to confuse now. But you can put it. There's nothing wrong in putting it. Okay. That is how it is. They skip it if it is obvious that it won't cause any conflict, the input on this function. They skip it like this. Right. They take this to ChatGPT to explain this function. Right. This is a function that converts text value into a token name by using UTF-8 encoding text into bytes. So this basically converts text into bytes. Step one, here's step one. From text, for this token, the output that goes down there is token name. This says, give me some human readable text. I'll give you a token name. Perfect. Text is the input. Unicode text, like my token. Token name, a type that identifies a token. It's internally just a built-in byte string. Now, here is the function definition. We have got from text equals token name dot. That dot here is composition. Then we call another function an encoder, which is coming from this module E. But the function name is called encode UTF-8. You see, it starts with a small e, it's a function. You see, this starts with a capital T, it's a token. This uses function composition, the dot, which is this one. It's the same as writing. Yeah, look at what I was showing you. I said this was skipped. They shortened it. That is what makes this a little bit tricky. If I don't explain this, you are going to write wrong things. This input is there, token name, but they didn't write it just for, they always like shortening things. But in the process of shortening things, new developers get confused. That is why I prefer to explicitly have the variable of the token name so that this is clear. This untoken name, token name. Try to say untoken name, token name, then composition, then you give it here. Then it's converted back to text. Then this one takes a text, converts it to, look, this one uses this E to take the text into, and then you give it back to this token name, get this. This one reverses the above. What is common here? When you see an equal after the name of the function, you must know the input, this one here, is this side, always on the right side. You will understand this when we've done Haskell completely. But for now, I want you to work so that we document this Plutus. So I've explained this. Any questions here on these two examples? So if I ask you questions here on this one, you should be able to answer the questions. My first question is, what is the input type? What is the output type? What is the name of the function? What is the logic or the processing of the function? Are you able to answer those questions? Right.
Yes, sir.
Yeah.
Yes, sir.
Let's see if you can answer those questions. I think you will be happy with this. First question is, what is the output type of toString?
String.
String. What is the processing? What is the logic of this function?
Text dot unpack dot to text.
To text.
Perfect. Perfect. And then the other thing I can ask you is, what is the input?
Token
Token
name.
name.
Yes, token name is the input. You see, that's it. You got it 100%. What is the name of the function?
To string.
String.
Now you are clever. Let me give you something difficult. This one is easy. I know you'll get it right. Let me give you something a little bit bigger. Yeah. There we go. Yeah, I like this one. I'll take this one out. Very good. Put it on a separate screen. I'll make this bigger for everyone to see. I want the new people. Following those 3 steps, number 1. Block and others there, please answer. What is the name of the function? New people try, unless if you are not with us. If you are not following, you won't be able to follow. Try. There's no right or wrong answer. No response from those new people. All right, let's go to Krifina Rito Sevier. What is the name of the function?
Value of
Oh,
Value of
Lumeze got it right. Value of. Your value of is a capital letter. I told you functions in Haskell start with a small letter. I think it's a typing on the phone that changed it, but you are right there. Value of. All right. Now I'm asking anyone to answer. How many inputs does this function have?
3.
3 inputs.
Three. If you still can't see the inputs from what I have given you, you need some more training. Now, I want you to give me the output type of this function.
Int.
Teacher.
Right, it is not int, it is integer. In Haskell, integer and int are different. Write it down. Int is bounded. It's 2 to the power something. It's bounded. I think it's 2 to the power 64. Int. Integer is not bounded. No one knows in Haskell the size of integer. It's a big number which no one knows. In my computer, integer can be it is as big as the memory my computer can handle. If you go to very large computers with big memory, that number is very big. Its size is controlled by the memory of your computer. So it's a very, very, very. So if you were to choose which one to use, int and integer, there are two things you need to know. Are you after safety or are you after safety? Do you have a lot of memory? Or you are after being efficient? If you want to be efficient to use little space, int is okay. But what is the problem of int? Because it's bounded. You are going to have overflow. Overflow. Which means if you give it a number that is over that limit, then you know what a computer is. It's a very stupid thing. It won't tell you what this number is bigger than what I can handle. No, it will do overflow. I don't know. If you don't know overflow, search it. You will understand what it is. Int has a problem of overflow. If you give it a number that is more than what that 2 to the power can handle. For example, you give it a number you need to compute on quantum computing, which are very big numbers. It will have overflow. But int won't. Why? Because it will be determined by the memory of your computer. That is how it is in Haskell. In other languages, we don't have an integer as big as this. Right. I'm very happy now you can distinguish the number of parameters. Okay. Now I'm going to ask a question. I've got this CUR. What is it? Are you able to tell, or you are confused? If you are confused, tell me you are confused. What is that CUR?
Currency.
Yeah, Lume says I'm confused. Who else?
The currency, sir.
You said currency. Now, you're partly right. It is not currency. What is it? Where is it coming from? If I were to ask you, where is this CUR? It's a name. For what?
A currency symbol, sir.
Currency symbol, not currency. Maybe I didn't hear you correct. Currency symbol. This is a variable name of this data type. This is a type because a capital letter there. This is a variable of this. Remember, you can create a variable like x int x, meaning x is a variable, but this variable will hold int string name. This variable name is name, but it will hold a string. Here the variable name is CUR. It is going to hold this. This is the data type. Why is it CUR? This person simply decided to select the first three letters of that as small letters. How do we know? I want somebody to tell me, how do we know this CU refers to this? It's not referring to this.
Okay,
How do we know?
Because it's the second input following the type signature of the value, currency symbol, and the token name.
You were able to see there are three what? Parameters, inputs. Same, we must have three what? Variables here. So we know by spaces here. The first space, we know this is the name of the function. That is how Haskell is. Separates by spaces. We know by space that this is what? Function name. First space, one space. Then here, the brackets are telling us this is the first parameter, first input. The space separates this. If there was no space separating this like this, then this will go together. But if this was like this, then this would be number 2. This would be number 1. Then it means number 1 is this one here. And then number 2, this one is this one here. Then it means this one is not used. How does Haskell show it's not used? They put this. This means this one is not used. Then this is a variable name of number 2, which is currency symbol. This means this is not used. Okay, in this function. But with the spaces like this space, this space, this space, it is the arrows on top are the ones that are separating the variables. Down here, the variables are separated by spaces. Okay, now let's go down to the logic. Let's plug this onto our spreadsheet. And let's see if this spreadsheet can assist people learn Haskell. Let's go to number 1. We say number 1, the name of the function is this one. Then here we need what? Inputs. And then here we need the variable. Right, we now list our inputs. We said there are 3. Right, this is the first one. I'm going to take it out so that it doesn't remain there. Which one is the second input? is this one. Then I have it there. Then which one is the third input? It's like mathematics. This one is one-to-one similar to mathematics. These are the three inputs. In mathematics, this was going to be x, y, z. Value was going to be equal to x, y, z, then processing. Right, then we have got these three. Then we know here we are going to have the equal sign. Right, we know here we are going to have the processing. Then after the processing, we are going to have our output. I want you to see one thing here. You have the equal sign. You have got the processing, the logic. This one here. After the equal sign, the processing. And then we've got our output here. Now let's take out the output type. The output does not have a variable. We only need to know. The compiler needs just to know what the type of the output is integer. Okay, that is what we have there. I'll have it there. Right, now you can give this any value. A value here is this one here. All of it with the bracket. That is the value. Value MP, part of value, like that. Yeah, remember what I said? This structuring. You'll understand when we do the types, data types, why we do this here. On the currency symbol, we have got that CU, this one here. And then on the token name, TN, makes sense. It's a shortcut for this one here. Now, let's take out the processing. What I want you to see here, you have understood that most important part. Now we get to the processing, the logic. I told you, the moment you are able to create the logic of a function, you are a developer. If you cannot create the logic, the processing correctly, you are not a programmer. The rest you can copy paste, they don't change. This part is where the problem solving actually takes place. This is the logic. Okay, I have been saying copy this, paste, but you can see it was easy when we were dealing with simple things like this one here. I want to show you here. When we were dealing with straightforward functions, those simple functions. This one. Maybe I need to go to the top. Yeah, we were dealing with a two-line function. First line, second line, then that is a function. Very small, very short. But now what are we dealing with? Now we are dealing with a function where the logic has got 4 lines, 5 lines. 1, 2, 3, 4, 5. Okay. This part is the most difficult part. What are you going to do? For me, I don't mind. Just cut all of it for the logic. Then down here, open a bigger space. Paste it for now. See, it's putting it on different different columns. That is my spreadsheet is putting it on different columns. Yeah. I remove space so that it's just all in one. And then it is in different cells, separated, fixed. I want it to be in one cell. Okay, let's see. You see what it has done? This is not what I want. So how do I squeeze all of it here? A simple way maybe is just to paste it and then merge. If I do this and merge, it might all go into, oh, it's failing. When you are using spreadsheet, Excel, hey, it's a problem. There is another better tool to use than Excel, guys. Otherwise, here, the only thing that can work best is a picture. It's just a picture where we just paste it as a picture. But I'm going to show you a better tool to use. But I think Excel for a start was okay. Then you can paste it there. You can see how of a struggle we are doing very simple things. Let me finish this just to show you the logic. So that means I can make it a little bit smaller. Then you can see the integer there. I'll make this like this so that you can see this properly. But we are all still on step number 2, processing. This is the process. Output is the integer. Okay. Following what we did yesterday, let's break down the processing into those columns that I showed you. A case of, you see here, we are making use case of, similar to switch. Case, if it is nothing, forward arrow, return 0. So our return type is integer. It's going to be 0. But if, what is m.lookup? It is a query. You are searching. You are searching. You are searching for this a map.lookup. See error here. You are searching. What are you searching for? Currency symbol from a what? MP. MP coming from value. So you are searching this here in a value. You are searching for a currency symbol from this. You might not find it. That is why here you are saying, if you don't find it, nothing, give 0. If you find it, I want you to look now. Just I return case map lookup token name in R. So map.lookup again. So this I is a collection. That is why we have got a second loop through list, which is R, looking for the token name. The list you are getting, second list you are getting, might not have the token name. That TN, this TN here you have here. If it is not there, return nothing, 0. But if it is there, just V. You return that value, that currency symbol. You return the value. Just v means return the value that you found. Nothing means return 0. I want you to see here, we didn't have the word return. We've got the forward R. Why are we having the forward R? Because we are in a case. When we are using case of, always use what? Forward R. You will see when to use the back R. How many decision-making statements do we have? We have 2. The first case is just like if. Search from the list, MP. Search for CUR. Don't find anything, return 0. You find a list and do the second search on the second list. This is the logic. Look through the second list, which is I. You search for the token name, this token. The first list you are searching for, the CUR, which is the currency symbol. And then the second one you are searching for the token name. So what is this telling us? You have got nested lists, complex data structure. So you need to search. I think those who are doing a Coxilip, you saw how we were drilling down through those complex structures. But you can see in Haskell is very simple. We don't drill the way we were doing on the JavaScript side. But on Haskell, it's not easy to really construct it. You need to know how to use case of with this. All right. I'm happy for now if we say this is the processing, which is the logic. We get back an integer. So what is the name of this function value of? All right, I'm not going to answer that for. Any question? Let me get some questions from you. Questions? All right, let me give you another one to do on your own. We check that you are able to do these functions. Now I'm going to use, here we've got another toString. Let's go down. I saw some longer ones. When you have got this and you see the lines, it's a comment, you can just delete it. But make sure you only delete the comment so that you are not confused on the functions that we have. Like for example, that is a comment. Then that's a comment. See, this is the function. This is the logic. One is straightforward. All these are comments. They are for the person to read, to understand. So they are not part of the function that the compiler is going to look at. Compiler is going to skip that. Here is another function here. It has got the following logic. I like this one again. Right. Now, let me ask, what is the, how many inputs do we have on split?
One.
One. Very good. I don't know. I thought you were going to say 2. What is the return type of split?
Maybe an integer.
Say the return type is an integer. No. Let's say do it here. Let's have number 1. Let's have number one. The function is called split inputs, and then what is the input here?
Value.
Value. Correct. This is the input. It's very easy to see the input. You see those double column and the arrow. That is the first input, and it's the only one. What is the output?
Brackets value. Value.
Bracket. Where is Daniela? What name do we give to this Daniela? Daniela, what name do we give to this? You've forgotten. But I'm going to reference the notes. Please, copy paste is going to kill you. Right. Among the data structures that Daniela provided, which one is that value, comma, value in brackets? It is one of these.
Maybe.
No, it is not maybe.
Sorry. A sequence of elements of the same type.
Daniela, you are the one who did this. I'm happy you did it. But now, did you understand it?
Okay, tuples.
It is a tuple. It is a tuple. You see their brackets.
Yeah, the example.
And then it has commas inside. Do you see that? It is a tuple. A tuple has got elements that are of different types. That is a tuple in Haskell. It is a little bit similar to a list. The only list, the brackets are square. The second difference is in a list, elements are of the same type. If it's numbers, it's all numbers. Strings is all strings. Car is all car. But a tuple, you can mix different types. You can have numbers. You can have numbers and strings. Here, this tuple for tuples, you can see it has three different types. It is a number one, it is a string hello, it is a bool true. That's a tuple. So exactly that is where we are here. This is a tuple. It is an output. All right. So we are going to put it right at the bottom there. That is the output. Output is a tuple. So we have got a value. We must produce a tuple.
Why are you on gas?
Okay, there we go. So that is split. Oh, that is why it's called split. You are having something you are going to split into tuple. Tuple is going to have value on the other side. Right. Now, what is this? I think I've explained that. That is the variable of the value input. Comes here. Input variable. That is the variable. MP is what we are going to use for our processing. Okay. Now let's get to the processing part. You can see also the processing will need a picture. But anything from here till here is the processing. So if I can put it in a nicer way, I'll just take a picture like this. This is the processing that finally leads to a split. All right, let me paste it. For now, we are doing this. I think we are going to move away from Excel. Excel was never meant for this. We are going to use a tool for drawing software diagrams called Draw. It's going to be far easier when we do it in Draw. But this is the what I want to show you here is the processing. And then the input, because I'm going to, okay, let me open this. That can fit. There we go. All right, let's have output there. And then I told you the output is a tab. I'm just combining columns and rows just to make it look better. You are not going to have this problem when we are using draw. Okay, so basically I think if I give you this now, let's reverse now. Remember I was giving you Bluetooth functions. And I was saying you produce that Excel part. Here is another function here that is interesting to me. This one here. It's called split int L, int left, split int L for left, I think. No, yeah, left and right. Split int L. Right, let me see how many of you can make sense of it. How many parameters are here? You might be it's very difficult. Follow exactly what we did before.
Like
how many parameters are here?
Like arguments, huh?
Yes, how many arguments are here?
Okay, one input and
one. Correct, is one. Which one is the input?
This is not map token name integer.
Very good. You look at this and this. This is the input. That is why that spreadsheet helps you. This is the input. Let me ask you, what is this? It's more like a sentence or a paragraph. What is this? And even to read it, it's very difficult. This is the output. All of it is the output. Now you might be confused. What type of an output is this? With like a sentence, a paragraph, like a maths. It is the output. It is the output. For now, to make you see the output easily, delete this map.map. Map.map is the map you have in JavaScript. It means it is a what? There is a list. A list. Just delete this. This means list. Map.map. When you see the word map or map.map or map.map.map.map.map, you know it is a list or nested list. Finish. I've deleted it for it to remove confusion from you. Then we have got same things here. We have got token name integer bracket, and then with the bracket Then again, we have got, this is repeated twice. Token name, integer. And then here we've got these. Remember, this is a type, these. Now you are able to see. Now I want you to delete this, replace this with L for left. Delete this, replace it with R. You see now, becomes easy. We have split this into left and right. Basically, we have split this into left and right. We have split whatever we got here into, but remember now here they are saying L, which means they are going to be interested in the L part. Let me return it. You see, from left, right. To put brackets, because we have got spaces. If you don't put brackets, then it becomes ugly. Now, if you remove the brackets, then it becomes very difficult for you to follow. Why? Because of these spaces. So this is a structure, okay, with a token name and the number. This is a token name and the number on the right side. There we have it. At the moment, I don't know what this stands for. I have to search. You can check with ChatGPT. There are so many terms you are going to come across you don't know. You'll need to use ChatGPT or any other AI tool, get information on this. I'm going to warn you. Bluetooth is new and is using tools which are not very common. So our ChatGPT does not know how to compile it. And number two, might not even know some of the modules. So it might just hallucinate, give you wrong information. It is only when you put it on the actual Bluetooth compiler that you'll know this is the right or wrong. But for now, we'll rely on that because it's going to give us 60% assistance. Right. Now let's get back to, I have explained to you, this is the output. If you don't understand the output, don't worry. As long as you know it's the output. And this is the input. Happy? I'm happy. Now this is the input variable. They just abbreviated MP prime. Where are they using MP prime? There. MP prime. Now here comes lambda expression. This is a lambda expression. It's another expression. You see, I told you I don't know this, but now I know where this comes from. It comes from map. It is one of the data types that is returned by a function called map this. Map this. Right. We are going to have an input I. If I is less or equal to 0, then this I, take that I, return that I. Else, return that I. That is something different from this, although it's all a number. Then you loop, because it's a map. Remember, it's a map. So it's a list. You loop through up until you end up with a list. What are you going to have at the end? It's a list. How do you know? Because you are collecting values that are less or equal to 0 as this. Those that are bigger than 0, return them as that, as a list of that. Might be a little bit strange, but if we see the actual list, you might tend to understand, oh, but in this case, It's a function they created. That was a little bit of a complicated function. I like. Now, with this one, the processing is this one. There it is. All right. I think, helped you a lot with functions. I think whatever function I give you now, you must be able to write the, what do you call it? The illustration for it. Because what we just want to map this in a human readable way, so that from a new developer, you can create your own function to here. So creating a function without logic is easy. Give it a name, give it input 1, here is the input 2, output is bool. That one is very straightforward. Then repeat the name down there. Now we are defining the function. This is the left, this is the right. Then now we process true or false. How are we processing true or false? We look at these two left and right variables, which are inputs. Right, the first thing here we check bin. This is another function. Maybe it's a helper function defined above. Use this function and another function. This is confusing with Haskell. When you see a symbol in brackets in Haskell, it is a function. For example, if you see this with a plus, it's a function. If you see anything, for example, let me say percentage, like this, it's a function. That might be strange to you, but remember, it's a function. It has got a type signature. Even when you see something like this, you see very funny things, even with the star. I've seen so many different functions, something like this. Even something like, I think I've seen something like this. Tilt. Yeah. So Haskell creates millions of different functions combining simple, but you'll see them with a what? With brackets around. So that is why I'm telling you this is a function. Probably checks which of these is greater, and then takes the greater and supplies to this. This is a Boolean end. Then this is another processing. But this it will check. This is a function which checks the right is 0. And this is a function also we see 0, checks the left is 0. If the left is 0 and the right is 0, not negates. True gives true, then you get a false. This is false, true, then it's a false. Then the negation of false is true. This is Boolean logic. Okay. Then you check this part again, it will be true. That is why at the end we are going to have a true. Here you can get it right if you know your truth tables. Let's suppose this was false, this was true, this was a true. What are you going to get? So from this side, you have a true, because let's say from this side you get a true. What about from this side? False, true. Anything with a true is false. Then now, if this is false, not false, then it's a true. True and false, or true and true, then you get a bool. That is the Boolean logic. Remember what I told you. When you do this Haskell thing, you will know things better. You can give me another programming language where you did something like this. I doubt. But remember again, I told you, this is a function. It's a function. Probably a function that checks if things are greater or equal. All right. Let me browse again. Here is another interesting function. This one, very interesting. This one is also very interesting, but I think you can identify it now. Going to ask you questions. I think people now are becoming more and more clever. That is very nice. How many inputs does this function have? Yeah. Silence means we are thinking. We are thinking because it's not easy.
3.
Good. I need another answer. Xavier says 3. Do you all agree or disagree? If you disagree, give me your number. How many inputs does this function have?
I think it's 5.
5. We have 3 and 5 now. Others, what do you say? How many inputs does this function have? Come again?
4.
4. We've got 3 answers now. We've got 3, 4, 5. I'm going to give you a trick that will help you know the truth. Let's go down to the variables do we have. How many do we have? They are separated by spaces. How many variables do we have?
3.
3. How many? Right, here now, how you can get this right. This is what you can do. We all know this is what? The return type. This function is going to give us a true or false. So you take out this, delete it. What you are left with is our inputs. But now our inputs are not one word, arrow, one word, arrow, like before. You have got some arrows, whatever, with a group bracket. So this is what you do. Where there's a bracket like this, take it as 1. Okay? Then where there's this arrow, take it as another one. So Xavier was right. We have got 3 inputs. This input is the function f. You remember yesterday, we were putting types and we had f for a type. Let me show you yesterday. First one we did, this one. I think this one was good. Now I realize we removed something that was good. Look, we had this input here. Byte string to R. Said it's a function. We had another input there where we say text to R. That's another function. I think it makes things easy here. This is a function. It is the input. In Haskell, you can have inputs which are functions. You can have a function with inputs that are functions that have got inputs. Now, let us map the f. We said this is equal to the f, but the f is a function. How many inputs does this function have? Okay, follow what I told you. 2. The last is the output of the f function. So the f function has got 2 inputs. It has got the first number and the second number. It will give us back 0. Now this makes it clear for you. Here, when they just say F, one letter, it becomes extremely abstract. But that's exactly what this F is. It is a function that takes an integer and another integer, and it will give you what? A Boolean value. So it will take two integers and give you a Boolean value. Okay, that's the function. That is its job. You don't need to know how it works, but we can guess how it works by seeing how it is used down here. Let's look at where F is used. Here, F is given A with a 0. Here, F is given a 0 with a B. Here, F is given A with an A. So you can see F is processing these inputs. Now, let's get back inside here, the logic now. If you look here, A, what is A then? It is any type, could be a string, could be a number, could be whatever. But if this has a 0, we assume it's a number. This is going to return something. This A, you apply that. If that B, apply F to 0 and B. But however, if these, if we've got A and B, then apply that function to A and B. You see how this thing is concise? This thing is so complicated, but they're writing very few things. This is actually saying it's a function that takes this integer and that integer and returns true or false. Therefore, we know A and B are numbers because this will crash if they are not numbers. Okay? Remember our let in binding. Our let in binding. Okay? In the let in binding, we have got a variable created. This one. And these. And then here, we first process this. We check this case of this K prime. This K prime would be this, or that, or this. Then we process, and then we take on this here with this. Then we have got check predicate. That is what you return. Then it will return true or false. With 2-3 examples using this, then you are going to know how this check in rel works, or you'll see how it works. Here, I think we have learned a lot. We were just documenting functions. But in the logic part, the most important things that we have learned let in. Guys, practice a lot of this. Let in. Case of. Okay. And then with. Remember the other function is the with. What else did I leave out? The do. These. Oh, we are going to be using this until you die in Haskell. These, they are the branching. If we compare this to our normal languages, a let in is for local bindings. They call it local bindings for local variables. If I want local variables that I'm going to use locally, like in this case, I want to use this up here. you put it in a let. You want another variable to use, you put it in a let. Where are you going to use that variable? In your expression. That is how you use the let in. Case of is the switch. The normal switch we have in JavaScript. Switch or case, or the normal case we have in PHP. The only difference here is we are used to writing it in a different way. In Haskell, case something of is this to say if this is that, then do this expression, then do this expression, then do this expression. It's different from a switch. The switch will have something like A, return something, B, do processing and then return something, else. But this one is no else. There's a case like that. Yeah, another thing here, let in case of where do is guards. Guards is a symbol, this one here. We have not get an example where they are guards. Guards stands for nested if, else, else, if, else. So you use this. If I put this and say 5, I'm saying if the is 5, it's a guard. If 5, then do something. The guard can have something here for now, can have something here. And then the guard ends with a word otherwise. So I'm going to give you this practice a lot so that they become more and more familiar as you use this. Let in case of where do the guards otherwise. So when you get you meet them, like in this case, what are we meeting? You meet a case of meet a late in. All right, I'm going to close this one here and open you for questions. I've got meetings today. Thanks those of you who tried doing those functions. I think they helped you a lot. I'm going to introduce some tools and diagrams. And from there, I'm going to leave you. Okay. And then I'm going to give you each a module. I will find time, then each one of you, I'm going to send you a module like this. Then inside the modules, you are going to have, what I want you to do when you get a module that I'm giving you, delete anything above like this. Delete it. Then delete all the imports so that they don't confuse you. Take out all the imports. Be careful in your deleting. Delete all the comments. You'll see the comments like this is inline pragma, delete it. This one, leave it. Or anything that has got makeshift quote, single quote like this. Normally it refers to this on top. You can delete it also. This line you can delete. Leave this line. Delete the comments only. Line comments, take it out. So that it becomes clearer what you are working with. See what I'm deleting. Don't make mistake and end up deleting what is not a comment. Like you might end up deleting this. Then your whole code becomes wrong. See, There's no comment here. There's no comment, no comment, no comment. Leave it like that. See how it is branching. Don't delete. If you are not sure, then leave it. This, take it out. This is a line pragma. Where it starts, where it ends, you can see. Take it out. See now, here you've got a long comment. Dash, 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 dash. Be careful when you are taking out that. Take it out. Then I'm left with a new type. I'm just cleaning so that at least when you do the work, it's a little bit easy. There we go. Then the makeshift, we don't need it. Just take it out. Now, the instances, these are very important, but this is not important. This inline pragma, now I realize here it is important. Guys, here it's important. Here it's restricting this, only this. I don't know. For now, no. I don't take it out. Then it makes this one wrong. I don't know, the line pragma. But remember, we are drawing those diagrams. They are not going to be fully representing this. There are too many things here. We can't put everything in a diagram. See, like this. This, actually, let's do this. Not to do it the proper way. When this is between this here with this word, don't delete it. The reason why they put it here is to say implementation of this EQ is okay if you only do this one. Like here, this is okay if you only do this function. So like I told you, these are functions. Right, don't delete this. Don't delete this. I'll tell you which one to delete. But this is an instant module. This one, we don't delete this. Right, you see this, it's a paragraph comment. It ends here. Take it out. See this one where it's on top here. It's different from the other one that I showed you. Did you see this one here? This one, take it out with this comment. They practice a lot up until you begin to be happy with what you have. You see, I've done this function with you now. You see the patterns. This one here, let's take it out. It's a comment and it's a pragma. What is a pragma? A pragma is a directive to the compiler to do something. At the moment, this is a pragma for the singleton, but on our diagram, we don't need it. This one. And the dash dash is a comment that is explaining. Compiler doesn't run that. You see, here is a union value function. It ends here. Remember, the indentation in Haskell is very important. It's very important. So the let in, what is inside is in the scoped here. Right here, we've got this scope pragma, the union with. Take it out. Here is the union with. This is a comment for num operations, pragma, and then that's a comment. Take it out. This one is a pragma for check. Take it out. Now look, check thread. Check thread. This is the first input, second input, third input, output. Those are the variables we did. It's good. This is a pragma. This is a line comment. Take it out. This one here must go all the way to this side. On values work. I think this is carrying on here. Here is the function. You see here between the function there is a comment. Take it out. This one here, take it out. This is for the greater than GT, greater or equal, less or equal. Take it out. Then we take out this one. I think I've repeated this so many times that now on your own you can be able to do this. So Lord, oh yeah, I'm already finished. Let me just finish here. Space here. I want you to see these functions. There are two functions here. But the difference is the second function is indented inside. It means this second function is a helper function for this. That is what it means. It means the processing here. Let's see this. Wait, you see they are using it here. You are processing this using this function, but you create it inside the split. You indent it. This is a helper function, helping split. Can have many of them, but you'll see them by indentation. So that is what we have to see them. Right, let me show you how I have cleaned this. And then from there, hello? Right, I will call you here. Let me close the meeting online. Okay, let me show you how I have cleaned this code. Preparing it for, what do you call it? The job that I'm going to give. I said make lift, take it out. So I'm leaving one spaces between just functions just so that you can see. Now, here is your job. This part here, between module and where, is a list of functions that are exported. So I'll show you how we are going to document this and which tool we are going to use to document. But so these are the functions which you see down here that are exported. This currency symbol is this new type here. This MPS symbol, you'll see it down here. MPS symbol, there it is, the function. Let me show you the tool here. This is what you are going to do. You are going to use this tool. You'll download it onto your machine. Let me start with number one, this one here. What you see here, this is the name of the module, which is this one here. Okay. And then the exported functions these ones here. These functions that are below here, but they are exported, which means when you import on the other side, you're going to use them. Let's go with this tool here. I'm going to take the first one, singleton. Here. It's just, when you are using this program, very easy. Just click here, say add new node. If, for example, I want to create something like this, you see this is purple. Why is purple? Because it's a link. When you go to the diagram here, you can see these lines. It is those purple things. Let me go back, remove singleton. Where is singleton here? Yeah, this one. Going here, I'm going to remove it as a link. When I click outside, you will see there are two square brackets. So I'm going to remove them. So now it's no longer a link. Singleton has been removed from this module. So if I go to the diagram here, you're going to see singleton now is on its own, is not linked. Before I carry on, I need you to ask questions. I have not given you this program. I'll just give you install it on your machine, download it and install it. That's very easy. And it's very easy to use because you just put it in one folder. If I can show you here where I put it. It's an EX file from my side that runs from one folder. So I put it here. I created a folder, I called it draw. Actually, I should give it another name. In this case, I am doing ledger. So I can give it, instead of draw, I give it ledger. Then I put the program there. On Windows, I don't know how it looks like. But I think it works the same. It's an executable file. You put it inside the folder. And then when you run it, it will open like this. Then it will say, when you click the first time to say create a node, first thing like a node like this one, it will ask you where do you want to save all your files. Then you save your files where this application is. Here, it will create a folder, okay, and then put everything inside. So all the things that you are seeing here, you see here, they are files. All these are files in that folder. If I open this, see they are files. At the moment, most of these files are empty, except this one. Do you see this file, how it is like? Exactly like this. I have taken out this. I removed the square brackets, simply double square on the left, double square on the right. Square brackets makes it a link. If I remove any of these, let's say token name, take out this, or it's not allowing me because it is running. It's not allowing me to edit it here because it is running. You can edit it this side. Come to token name here, take it out, move those two. Then when you go to the, you don't save here. This app, we don't save. It saves on its own. When I check the graph now, I've got singleton. It's a function. Token is a function. It's no longer linked to the module. So when I click module, they are no longer linked. How do I link it back? Add those square brackets. That's all. Let's come beside. Okay, so now all of them are linked. I'm not saving. Moment it saves. There is no save button. You click there, see all of them are here. Now, this is what you are going to do. First easy thing before you even do the function stuff. Let us take one currency symbol. Under currency symbol here, I want the what is currency symbol? Then you come back to your file, this file. So when you have done those things, then you delete this. Because remember now, the exported, I've linked them. Then I go to the currency symbol. The currency symbol is all this, what you see. Cut it. Just go to that file, currency symbol, paste it. Right, let's go to another one, which is the other one that we have. Let's follow here. Map S symbol. All of it. Cut it. This is pretty easy. Then we look for map S symbol. This one. Paste. Maybe you didn't see me create these files. How did you create these files? All right, I'm going to delete the file to see how I created it. Yeah, I think that is the best. Or I create a new file. I go here, it says the home. This is the first one I created. When everything was empty here, I created this. I'm going to create a file, Bernard, and then put something, a function of Haskell inside Bernard, so that you see how they link together. To do that, you only come here and click here. Then it says untitled. And then here, you type. It's a function small letter. It's a type capital letter. A. Then it's a type. Finish. The moment I click outside, a file Bernard has been created here. In Plutus here. Which one is that? Oxygen. Right, I'm here. So inside here now, you will find there is a Bernard file. But when you open it, it's empty. Right. Now, I'm still on Bernard here. I'm going to add children of Bernard. In this case, it is a module with functions and data types. You will add those functions and data types the same way you copy paste. Here I'm showing you how to create a file and the children and link them together. So Otilia and Bongiwe are not yet files. They don't exist, even when you check under this graph. They are not there, even Bernard. You see Bernard is here. When you click, you only see this. Now I'm going to make Otilia a file. You make it a link by putting square brackets. I click. Now, when you go to your folder, you will find a file name Otilia created. All right, let me click on the graph. Yeah, I have to click out, click on the graph now. Here. I want you to see now. Do you see Bernard is linked to Otilia? I can click Otilia now. Do you see now the file is there? I didn't create the file. Otilia is there now. Let's go back here. It's just a demo to creating files. Let's go to Bernard. There. You see, Bongyo doesn't exist as a file. But the moment I make it a link by putting these two squares, immediately a file Bongyo gets created. When I click graph, now look, I want you to see Bernard. See, Bernard has two children. These two. Let's suppose Bernard was a module like ledger, like script context, like TX, like cryptocurrency, TX info. And let's suppose those two, Otilia and Bongyo, are functions. This is where you come in here, on what I showed you here. You copy those functions there. Here. So I'll just come here and say, all right, function for Otilia, there it is. It is the currency, whatever. And I click outside. I can go to what you need to see here. Otilia has no link to the parent, but the parent has a link to the child. If I want Otilia to link back to the parent, all what I need to add the parent on Otilia here. Either you add it here in square brackets, like that. Do you see, even when I say square, square, then it puts the last closing square brackets, then it shows me the list of files I can link to. Now I have linked Otilia back to Bernard. Can do the same to Bongyo as an example. Bongyo doesn't exist here now, so I have to go back to Bernard. Where no, Bongyo does exist now. I can click Bongyo and then open square bracket, then Bongyo must link back to Bernard. Then click outside, and then now go to Bernard. Now you can go to the graph. I want you to see the graph. Now from here, I can go back to Bernard. From Bernard, I can go to Bongyo. From Bongyo, I can go to Bernard. I can go to Otilia from here. Can navigate around. So now let me go back. The Bongyo now exists at this side. Let me put the function for Bongyo. Make a space between your links, like in this case, I need to add all these functions. There are two ways. This is the exported functions only without showing us the actual function definitions. So now when we want function definitions, we click go inside. Then we have singleton. Where is that singleton function? Then you copy it, there it is. Going to cut it. Then you paste it. But singleton must link to the mother, so that when I'm in the singleton, I can go to the mother. And the mother of singleton is this one. You can do this. So now this is the singleton. Now we will take it a step further. Now I need the diagram for singleton. Change order. How do I import? I don't know now. I need to import a picture. I don't know. Let's check here. So split name. Where is import? Export. You can export this as a PDF. I have no idea how to import a picture. Maybe we need to edit the picture here. Let me check if I can have a picture. Right click, insert. Yes. Yes. I have managed to import a picture there. Yes. There is the picture. When I delete everything here, it also goes and deletes. But that picture is still there. Okay. Now let me add the pictures that we were doing. Let's take, for example, the singleton. The singleton function. We have it this way, or this way. I don't know how. Let's say like this. This explains this better. I'll just take this as an example. Or let's do the ones that you did before. But remember now, I'm going to move you from using this to actually using a proper software development diagram. But for now, let me use this as an example. Just copy this picture. You go here. Let's suppose this is the correct picture. Then you paste it. Perfect. I love it. There it is. Actually, it wanted you to give it a name, a correct name. But you can see now this picture, there it is. And then now, if I go back to the singleton here, I don't know if I can change a name, but I don't change a name. Leave it like that. So what this does now, it gives us more power than what we had before. How do I go to the next? Yeah, this is what I want. Now we go to the ChatGPT now. We get a tutorial on this singleton function. This is what you do. Come here and say, produce a tutorial on this Plutus function for a beginner. I think that is all what you need. Add simple test code. Normally, ChatGPT doesn't know how to compile Bluetooth. It will simulate something. We'll replace it later when we are running Bluetooth. Because we need examples. Without examples, how will you know how to use it? Maybe give 3 examples. Give code examples. 3 test code examples. 3 test code examples. You see, from 3 examples, then at least you have an idea. Then let's copy. Then ChatGPT is just going to create a simple tutorial there, which is perfect. There it is. and then it will give, here is where it's going to always make mistakes. If you take this to the main, it might not run. It will not run. You can test it. If it doesn't run, there's nothing you can do, because compiling Bluetooth code, ChatGPT doesn't have those tools. In future, maybe it's going to have those tools. But for now, for learning purposes, you know what? It is a big step going forward. It will give you output with dummy data, which is better than nothing. Example 3. Then I want to copy everything. Copy this. Then I go to this here. Then I paste. Perfect. Then you remove this this part here. Then we have got perfect documentation. It's not perfect, but better documentation for this. Far better than the Haddock. Far better than the Haddock. But if we were expert Bluetooth developers, we were going to use this, write more explanation, really give examples that are coming from actual builds. But for now, this is okay. Now let me show you now how this works. Go to the graph. We are going to take this graph. In this case, all right, this was a demo there. And then we are going to export this graph. Or we are going to export this as a website. Once it's a website online, people who are learning Bluetooth now, they are just going to come in, all right? Start time-lapse animation. Okay. Then they say, all right, I want to learn about that function that we did. Singleton. Then you check here for singleton, you search for it. Then singleton comes out. In this case, when it comes out, or when you come here and you put your mouse here, you see, it highlights the children. This is the singleton. So you click here, takes you to Bluetooth ledger. You can either click here, then takes you to the singleton, or straight from here visual, you get the singleton function here. Then you click on it. Right. That is what you are going to do. I think we need to list down the steps, step by step. Let me close this. Let me give you the link to download this Obsidian. It will, you are in Windows, so you can download it there. I'm putting this Obsidian on Oxygen Global, and I'm putting it on the Discord. There we go. I'm giving you examples. Oh, Jesus Christ. What did I do? Why am I getting calls in Discord? All right. I'm going to also show you the folder. You see here, there is that file. Here are the different files. Okay, we don't need this. I'll delete it from there. And I'm going to go to the draw here. And I'm going to run this one. In your case, you run your own. And it will come like the way you see it here. There it is. So I can have a picture of this. so that you can follow on this one here. There is this one. And then the next thing, the most important thing I like most is this one. I like this one. Let's have a picture of this. Because it's dynamic, you can collapse it. There we have it. And then the next thing here, singleton. Where is singleton? Click singleton. See. Then we put the tutorial. Now, where you are going to change, you see, we are creating these functions using this Excel. Excel is not a tool for software developers. We're supposed to create this singleton function in the correct, what do you call it? Correct. We're using the correct tool. Let me show you the correct tool. It's easy to use. It's easy to use because you already know what to do. The tool is called draw.io. And some of you might have used it before. This one. It's called draw.io. Excel was just for demo. It was a poor, I think it might confuse you, but enough. How do you then create using that? So we follow the same structure we did using these draw functions here. We are following the inputs, whatever. You've got how many columns? You've got 3 columns, basically. You've got 3 columns. So you can select any shape here, which has columns, or you can split it how you want it. It's up to you. I have no idea. Yeah, that is the best thing to do. You can start from the beginning. This one is easy and quick, better than Excel. Background color. There should be no color. Right. So with this one here now, we need 3 columns. We've got lines to draw. And these lines are straight. They are better than the ones that we were having before. It's up to you which lines you draw. But let's all use the same lines in the line. Right. So how do I draw a column on this? Click on it. You pull one side of it. Take it to where you want it to snap. Then pull the other side. And then let it be straight. When it changes into green, do you see now? I have created a column. So if I need another line, I click out, then I get, this time I need a horizontal line or out here. Okay. If you move inside, it creates a problem. See, you can't go inside. So you move outside, then you come outside, then move with the outside. It moves fine. So now look, I have created that Excel thing that we needed. Here I need the name of the function that I have here, the singleton. Cut it. Then I need to put the name there. Use text. Why is this text? Color. Font color must be black. Yeah. And there I paste singleton. Then you just move it to where you want. You are going to enjoy this one. There it is. This is the name of the function. Then we need our inputs here going down. Can duplicate this, I think. Yeah. Then we are going to have inputs here. Outputs. No, it's input. And then remember, we are going to add that column 4 times. Like this is a function. Make it more clear. And we can say variable names for now. But I think we need that one here. Inputs. And then let's say variables. Right, we can follow this. We've got 3 inputs. First one. Duplicate. Second one, token name. You right click, duplicate. Double click inside to highlight. Paste, click outside, then next input. Right click, duplicate. Double click inside the text, paste. So this one is very fast. If you want, you can align them outside. I think there is an alignment tool. Where is that? Alignment to the left or right. Okay, I think they are in a line. Then we move them together, can group them. Oh, yeah, there we are. And then maybe if you want distances, you've got the grid lines. If you want distances, it has to be professional. So you can see this one is lined properly. And I can bring it here. There we have. And then we can have the variable side. So remember now, these things are not grouped. So you can move this, it's not yet grouped. So it's always good when you have put your words, group it. 2, 3. So this one. So you'll be assisted in aligning by this tool here. It will assist in aligning your work. So now you are really using a proper professional tool. You see. Then the variable for current symbol according to this is what is a C, TNI. I hate that. CS, let's call it a C. Token name, TN, integer, R. And then the processing. The processing. Let's duplicate this. Double click. Right. I'm happy with this because this one really it's working like a proper tool. Even when you put your equal, remember you need your equal somewhere here. Now you can then put your output. Output is what? Our output is value. So let's have the output here. Okay. Right, you can see you can use the grid lines to align your work. It is aligned. And we can have this part here. Remember input. If you want to do your numbering, yes, we can have the numbers. Now let's add the lines. And add this line here. But I need it shorter. Okay, see that. And then this one is going to be a long line to separate this part here. One is okay. Copy line. You make sure it's selected, then you copy it. There we go. Copy paste. Here we are separating the processing. Copy paste. We are here. Right. We are done there. So we didn't really need this other part. See. Okay. There we are. And then from here now, what we need is to add those processing or logic. And then output. See, this one is very fast, very neat. It has got some things to assist you along the way. Let's call it output. Right, let's suppose you are happy with your work. Let's go back, Control Z. Say you are happy with your work. This function is okay. Now you want to, let's check here the processing. It's got all the variables, token name C. There it is. Value processing, there it is. And put it in the center. Put that in the center. think we need a vertical line for these other two. So copy paste, then move this. But in this case, I want it here. Here we have fit. We have a vertical line to separate the variables and this one. What else did I leave out? Function name is a singleton.
Everything is complete, sir.
It's complete here. So then here you take a picture. You can take a picture, take a screenshot, or you can make it a picture. You highlight all of it. Then you group. Click group. Now it becomes a picture. See, everything now is moving. There's one picture. This is a tool for software, and we are creating a software. And I think you can right click and export. I don't know how to export it now.
Maybe you can copy.
I think you can copy it like this. Let's go back to our site. See, we replace this. No, it's binary. That one is binary. So we need to.
So you can put the file. You bear with it in file on your top left.
On my top left.
Yes.
Here.
Yeah. Then you can say save as.
Oh yeah, export is PNG.
Yeah.
Yeah, correct. Because you will export it as PNG straight to where you want it. JPEG is smaller. There we have it, diagram, export. Then we have the name onto the device. And I have it there. Yeah, that's exactly what we want. You can copy the file name to that folder. Or you can use the snipping tool. And then after here, go straight to your program. Edit it. There we have it. Let's check it. Then if we check singleton now, do you see how it looks like? Now, if I come here to singleton, then I see the Haskell singleton function. Then I see my diagram that says singleton inputs. Then I can see currency symbol is the first input. It is the C. This is not clear to a new person. What is the C? This C is the currency symbol, the token name, integer. You can put lines across if you want. And they are used in the processing here. You see, this function doesn't show you what is the processing, but this one here says processing value, this dot map, or this here. Then the output is value. Now, later on, why this tool is powerful? Later on, because we have got value here. What is currency symbol? Because here people must know what is currency symbol. We can then come here, link this to the currency symbol. This is where the power comes. Telling you, this is far better than what we have. And then again, we want people to know what is value. See, you see, I've linked them there. Now, the other thing we can link to is map.singleton. What is map? What is singleton? Map.singleton. But then that will be too far. For now, I think if we know currency symbol token name, value. But I know that map.singleton function, it takes these parameters that you see here, 2 parameters. Because look here, if I don't know how this thing works, then I get stuck again. One way you can just maybe use ChatGPT to tell you what that function does, or what does it take, what does it do. And then maybe you can use this information that ChatGPT is going to give to you. Let's see what it says about map.singleton. Maybe I should have said Plutus because it might exist on the Haskell libraries. So it's struggling to find this. Let me say Bluetooth. Let's see if it is good. Yeah, I should have mentioned it in Bluetooth. You see, it is coming from Bluetooth tx.asocmap.map. And here is the signature for it. It takes 2 inputs, a K and a V, gives us back a map, which is a key value. This is a very important function. You need it. Therefore, you need a file called what? This singleton. Therefore, here with this tool, we can now add a link. Okay. What I have done here, you see, this thing is so powerful that now it has created 4 files for us. It has created this currency symbol. It has created this map singleton. It has created it. So if I go here, they are not yet, they will be linked to singleton, but they are empty. So if I click here, do you see they exist now? There is the currency symbol. Look at where it is linked to singleton. So when I click currency, currency symbol is there, then it is fine, but it is not mapped to the other ones. Now there is map.singleton. It's empty. This is where now you just click, it opens the file that already exists for you. And what do? Come here. You copy that for the singleton now. Yeah, copy that. And let's put the tutorial for the singleton. Like this. So that if somebody now doesn't know what is singleton, can come here and then you can look where it's coming from. Output. When to use this. I like it, it explains here. All right, for now, this is what we have. This is what we can work with. And then if we go back, we've got map.singleton, we've got something. Now we need to map back to where we came from, which was what? It was currency symbol. No, it was singleton. Yeah, there we go. There's something else that is good with this thing here. And come here, when you hover here, like this, when you just hover your mouse there, press Control, it opens to you the parent can see it from here. See. So when I click here, see, come back here. This is great documentation for Bluetooth. Now, what questions do you have? I have shown you the tools that you need to use. You need to use this draw. Okay. This helps simplify. It helps simplify where we are. If now I can give you this, now you can see, yeah, definitely it is far better. We don't need to do it for Haskell. No, Haskell is only the, what do you call it? It is taking us to Plutus. This is the Plutus. This is what is going to make you great, creating smart contracts using this. So I think this is my last, my time is gone.
Yes, sir.
So instead of this, right, this is the draw now, and the draw mixed with Obsidian. And then if you see this side, if I go back to this side,
Yes,
I
sir.
have not checked these other things. What is this canvas? I don't know. But I'm concerned about what we need for now. This is all what we need. How do you delete something from here? You just click it this side, right click on it, say delete. And it takes out. Like for example, I have to take out Bernard. It was an exam demo. And then I have to take out one out here, because now I am also going to do this using this one that I have already started. So what I'm going to do, I'm going to give each one of you a, what do you call it, a module like this. It will be a module like this, complete module. You are going to do the functions, okay, the way I have shown you here, like this. The things that we have not done, which you still need to do, are the instances, the type classes, the types, these ones. Because every module I'm going to give you, I might give you two. Then you do and complete those. That will be before the end of this month. All those who are new must work, complete those two that I will give you. I'll put you on the list for the payroll. You need to do it correctly. Like this will be for one person. This one already for the ledger value. This is ledger value. It is for me. This is for the ledger value. So we have got all these. I will be giving you two, or three. Then you do this withdraw. To explain the function there in a visual way, this way. And then you'll need to also use the Haskell, the chat GPT, to explain, like here, get a tutorial on this. Then you use this one, Obsidian, to do this graphical thing. Any question?
Yes, sir. Not really a question, but I don't know if you can get the, when we were using
Come closer to the mic.
Okay, sorry. So when we are using the mirror app, you dropped a link which you're able to use to access it. So for this this tool you use, is it possible to share a link that we can directly access from our browser?
Yeah,
Even for
the
the Plutus
Obsidian.
IO as well.
No, the Obsidian, you have to install it on your machine. How you are going to give me back? You are going to send me this file, the folder, this one here. You right click this and compress it like this. Then you send it to me. Then all what I will simply do, I will copy all your files, these ones that you have done for your module, and I will paste them here. Then you will see this one. It will have all other modules. So it's going to be very, very, very detailed. And all your diagrams and all over, they will be here. This one you have to install it on your on a machine. It's the only thing that will need to install on your machine.
So the name is Obsidian.
Yes, I have put it here on the Discord.
Okay,
Discord
Discord, I've
here,
seen
there
it.
it is download Obsidian. And then I have put here for draw.io for this one here. And then what else do you need? Let me know. What else do you need?
I think that's all.
Yes. The diagrams for the data type and the, what do you call it? The type, the data type, I'm going to send them to you. I'm thinking of using these ones here. Let me just show you the ones that oxygen. Where are those? These ones here. I'm thinking of using. Let me show you this one here. This one here, a circle, and this one here, square data purpose. You see this one here for the script context. We don't need the module from what I see. If ever I have to add this module like this, it will be on the ledger, that one, the main file. But the ones that I need is this one here. See here, I made this a circle. So that moment I see more circles, I know they are data. The new type data. What you can see here is data on the left. This is the name of this data type. Deriving, we need all the deriving here, but there's something missing here. The instances are missing. Maybe what I will need to do, I'll need to convert this to this so that I've got this here like this. This is okay. Then I draw a line, I write deriving. I list all the type classes this data is deriving. This is where under deriving here, we are going to type all these things here. This one, this is 1, 2, 3, actually all this for this data. All this there. So we'll use this symbol. And then the other thing that is very important about this token name, it is the instance, these instances. In this case, the instance these instances. I will have to figure a way to add the instances onto the diagram, because creating a data like token, having so many instances is very important. You will never be able to use token without knowing these instances. Instance is string. No, I'm wrong. The instance for token name is 1. It's here. Only 1. This one, instance is only 1. This one for toString, instance is this one. I'll just give you the tools and show you where you put the instances. All what you need to know is instance show. What does that show have? Show equals to string. Instance to JSON token name. And then again, there's this logic for the instance. So, it's not that. As you can see here, how this from JSON. We are not going to do this. We are not going to do this. All what we are going to do is we are going to like toString. Under deriving, you see this deriving. I'm going to replace the word deriving with type classes. Let me show you. If you look at this deriving here, I'm going to put type classes. Then here you are going to list. You don't even type paragraph, you just list. Under deriving, you list this. You list this. You list all this. You list this. You list this. Just list. Where it's a new type, it's any class, you list. Then you list instances. Now, when you are listing instances, you only take like its token name. What is the instance? It's this one. Just list that. Token name. What is the instance? Show. So you list show to JSON from JSON. Then it's enough. Value. What are the instances of value? This one. And then go down, deriving any class, this Haskell, this one. So what is the instance there? It's this one here. This one. Then here, select here, Haskell EQ. You write it once. You see here there's EQ, Haskell EQ. Just say EQ. Here it is an instance of semigroup defined in the Haskell. See, there's also another semigroup. So you just write semigroup, finish. And then here you just write instance monoid, finish. And you don't repeat monoid. I'll explain to you why. If we leave out these instances, no one can use value. Where value has got some empty things, you need to use this function empty, which is an instance of monoid. Monoid belongs to the semigroup. So the only instance you can write there is semigroup, finish. That's it. All these other words, sentences, deriving via, no, leave it out. You can either write semigroup or addictive semigroup, addictive monoid, but at least if you push it 90%, the other 10% I'm going to follow through everything, correcting. The only problem, if you don't do anything, then I have to do everything by myself. I won't be able to finish it, but when you work, you guys, at least it's better for you, because you are also understanding, you are also learning. Any question? I know you might have some problems with instances and type classes. I will help you with an example. Say, right, here are the type classes that you need to list under this. Take anything that is on deriving, but the last things, these ones, the ones that are in brackets. That. Even if you list all of them in brackets, don't copy the whole sentence, it won't fit. Because the most important thing is this. All this for instances. Don't make mistakes, because toString, the instance is this one, instance. Then here is another function. See, it's another function. When you go to a type, it's type deriving. All these are type classes. Then these are instances. You see, like instance, this one, because this, sorry man, value, where is that? This one is confusing. Here you'll be confused. Total. This is where I will come in, fix, but at least put those instances. Here is 2JSON. Yeah, here is 2JSON. Some of these are repetition, I'll tell you, because you'll find here there is already a 2JSON from JSON. Down here there's an instance again to JSON. Again, instance of this from JSON. The difference are the implementations here. But for me, as long as there's 2JSON from JSON. So right, skip this. This repetition, skip it. You can't put everything there. So they are copy paste, copy paste, copy paste, instances and type classes. Copy paste. And the other thing, when you have got questions, send them on Discord, help each other. All right, good people, I have got to go. I've tried my best. This thing is exhausting. All night I was working on it. It's exhausting. You start on it right away. Submit what you have done daily. I won't pay if there is no work done. If you don't know, communicate, ask. Let people show you. That is what I can say. Any question from your side there? I'm stopping to. Today there are a lot of people. That's better. But let's get them paid end of the month so that they are motivated. So when you have got questions, ask. Xavier is there. He's going to help you. Post your questions on Discord. When I see questions on Discord, I'll go answer, assist. Post whatever you are doing on Discord. Any question now? I'm jumping out of the session now.
Yes, sir. Just the picture, just in case if you've not sent it to the group, this last one on the instances can also help us start
Right.
on Discord.
On the instances. Yeah, the picture for the instances, for the data type, let's use the sec. Let's use the sec. Then inside here, you just partition it the way you see it here. This one for the sec. Let's use the sec with this data tx info. Then you list the members. These are the fields. You'll always find them from this. When I give you your module, you will see. Then you will see deriving. Then you will see instances. I will remove this and put type classes. Then you list all the type classes from instances in here. Please use this circle with those 2, 4, 6 division. Why? Because I want, when I open, I see the circle, then I know it's a data. And I want a different diagram for a type. For a new type, I want a different diagram. That would be for data. For data, let's use this one. And then for type, we might use similar to circle, that one division, but we might use a parallelogram. Just one, the moment you see a diagram, that is a data structure. That is data, that is new type. That is type. Then we have the instances and the whatever below. Let me add this. I will draw one and also send it to you. Use, I don't know, is it the oval? Above for illustrating data. Okay. I will send another one for type. If I don't send, carry on, because I don't think I will have all these times that. We can have a parallelogram. Okay. We can have this shape. And then we divide it the same way we divided that circle. I don't know which other circle we can use that is better, easy. We can use this one. This one, closer to the circle, so that we know this one is let me take out background color. Okay, right. This shape is like that circle. I put these two here. This we know the oval like this. It's going to be the data. This one is going to be the new type. Then we can use.
So,
yeah,
you're no more sharing your screen.
This for, all right, let me share the screen so that you can just see. Right, let me go back to that draw. No, I'm not happy with this shape. Let me just simply take this one here. You just take any round edged shape like this. This one becomes the type. This one becomes the new type, the data, new type. and this one the type. Right. Let me show you how to divide this one here. It's very easy. If people come with something easier, we will follow. Right, let me come here, snap it there. So this one, when we are using move outside, it moves very well. Then it snaps, I don't know now, snaps properly from outside. Click here and then select it straight. Right. There we go. Now I want the horizontal line from here with this one here. It must be straight. There we go. And then you duplicate the line, copy, paste. But don't forget to, what do you call it? Group, so that you've got this picture. Okay. Let me add the line to this one. This one is going to be the type. This one is just to be type synonym. Type synonym will just divide it into two. Yeah, something like this. And, yeah. Then I divide one vertical line. When you move outside, it works fine. Like this, outside the shape. Then you go to the, what do you call it, to snap it from the outside. Then it works very, very well. I need the same, this one, and that one for this one. Okay, I'm happy with these shapes. Let me group here. Okay. Now, let me show you where you put your text. I think the text, like, so I need the text for the type. Let me start with the type. Then the new type. Then the data. Okay. Right. this comes here, this comes here, type synonym, it's a type synonym. And this comes here, new type. Something that I forgot here. The new type doesn't have, yeah, it does have deriving. Does have so the name comes here. You say type, the name comes here. Data, the name comes here. This one we have seen the example. Type, the name comes here. Then the fields, I think there's a mistake here. It has to be into 4 areas. Somewhere there. But so it has to be like that. Even here, you need to have divisions like this. Okay. Yeah. You can make the top row smaller, but I've just made it like this because you'll have to fit in the information that we have. Then this side, we are going to have type classes. Here, you listed them here, the type classes. Here, put the type classes there. Yeah. And something like this. A little bit down here. Then you put. All right, I think, let me check. Which example can I put here that you will all remember? Normally, a type, all the type classes show, they go with the type synonym. Like, for example, you can make a type of an existing. You will, I think, let me group this. I don't have enough time today to give you all information about type, new type. So do the best you can do. I'll see what you have done. What I will simply do, I'll simply divide for you. Yeah.
When are you gonna send us the models?
Let me send the. I think I can just try the modules. I can read them to you, those that are here. Okay, let me do this. File export. That one is the type. Let's save this one. I've got a meeting today, you know what? You know, let's take it easy because that's the work we need to do. This one is the new type. All right, now here comes where did I download these things on. Yeah, there we go. So I see how downloaded everything. There is the new type. Got it. There we go. And then this is the data. This is the new type. In all the four, this is the function. Function. Right, that will work. You follow what we have done here. That will work. You follow this. That will work. That will work. That will work. It will assist a lot. Right, now let's get to the type classes and then I can quickly give them to you. Set GitHub. Right, where is the Haddock? Then it is the ledger. There we go. It is apps. Ledger API 1, Ledger API 2. Right, let me give you the modules so that I rest. Good. First, here is the what we are going to do. Let's start with version 1. Start with version 1. Let's count 2, 4, 6, 8, 10, 12, 14, 15. I am taking which one? Value. So leave out value. But you can see version 2 is just API. And I don't know what is this API. Version 2, what is this API? No, this one is for advanced users, not for us. No, not this one. Context is there for now. We start with version 1. Evaluate context and Bluetooth ledger TX. Yeah, I think we are okay with this one. Then the same person who will do TX later on is going to do TX because there are some extra things that came with version 2. We are going to do this for. Let me have your names. Get it here. Modules. Right. Now I'm giving you names. Are you all here? I don't know who is here, who is not.
Yes, sir.
I might give people who are not here and they don't do it. I'll be very happy. It's better I give to those that are here. Let me, how can I do it clearly? Can we draw? Help me. Yeah, let me paste it here. And then give names. Guys, try your best to do this and finish it. Try your best. Right. I don't want to give anyone who is not here because it's not going to be done. I'll end up doing it. I'll only give those that are here. And again, the moment you have got a problem because you are doing something, you can't do it, let me know. I give it to someone else. Right, let me start with Rito. You are going to take the first. How many are there? 2, 4, 6, 8, 10, 12, 15. Leave out the last one. I'm doing the last one. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. How many are you here? Let me have your names. Xavier. What is the other? Content there. And Fino. Who else is here? Israel. Is Israel here?
Yes, sir.
Yeah, Israel. Who else? Let's see. Manasseh. I'm going to give you also. Well. See. I don't spell your word correctly, forgive me. I'm taking it from usernames. All right. Others are gone, they are not here. Whoever is not here must contact me to get this thing. For now, I'm relying on myself, Daniela, Israel, Nas, Prefina, Red, Sevi. Okay? We can all see it's just random. Just putting your name there. It's just random. Prefina, to the credential. Israel, to the crypto. You know about cryptography. Cryptographic functions. Then I repeat. Should have duplicated it there. Save here. Who else did I leave out? Israel. Script. Time TX. Let me do the last two so that I also see the problems we are encountering. Okay, this one. Who else can do time? There we go. Okay. Right. There is one I'm not sure about, that API. This one, Manas, I'll take API away from you. I've never seen it used in it. Give you time. Which other one? Versions. Prefer versions. Versions, protocol versions. This one, no. I'd rather give Prefina API. Take out versions, bytes. So, yeah, we have used bytes. Context is credential, crypto, delegated certificates, evaluation context, examples. I've never seen what is in the examples. What is in the examples? It's very few. See, this is all what we have. Oh, yeah, these are examples. You click here. When you open it, you click source. Okay, click source. What I'm going to give you is just this link. That's the link I'm going to put here. Right. I think that's it. Thank you very much. I think let's try what we have.
Yes, sir. Thank you so much, sir.
Yeah. There is the work, guys.
Thank you so much.
If you can try what I said to you, clean your way here, where I did it here, because the comments in those pragma directives are going to be a problem for you. You need this for doing that Obsidian exported function. Each module that you have, if you can check here, it has got the exported functions. Which one is this one? Serialize. If it doesn't have exported functions, then you go straight away to the type, see the type, data, and then you have the functions. To tell you the truth, this Haddock documentation API is for advanced users. It frustrates me a lot. Okay, I think we are making it better. If you think we are not doing it, if you have got some other better ways of improving, we will adapt. Remember, let's all be ready for changes, because people can come here and criticize and tell us, no, this is even making it worse than what it was before. Maybe we could have done it better by doing 1, 2, 3. We will adapt. These are allocations. They are allocations. Okay, there we go. All right, thank you very much. Do it even tomorrow. If I'm not around, carry on. Whatever you have done, you can post it on Discord so that others can check, and then you can correct each other. Each one of you, what you are going to give to me, you are going to give to me that folder. But before you give it to me, that folder, you are just going to take picture of that diagram. You'll take picture of this diagram here. Because you need to really know what are we going to give you. You are not going to give me this program, it's yours in your computer. When you run the door, this, you will have your first module. My module is value. It is Plutus V1 ledger value. Let's hope I selected the correct modules. Wait a moment. You see what I selected here? Let's see. Yeah, mine is this one, you see. Plutus V1 ledger value. Some of you are ledger.tx. Mine is this one. So basically, this is what I have. When I run it with my first file, the main file, I see this. These are the exported functions and data types of the whole ledger value. I mustn't leave anything out. So you can see it clearly without the what? Without the comments and those pragmas. Now, when the next thing is, you will show us on your PC, take a picture of that. And then we click here. Then we are going to see these like this. Then the next thing is they must all be linked. The second thing is they must all have illustrations. I showed you using singleton here. I showed you using singleton. When I click each one of them, I must have, is it a function? Let's have that code copied and pasted on top. If it's a data type with instances, you copy and paste it there. Link back to the main where you are coming from. When you create other inside links, it's very easy for the links. When you click here, it will go to the currency symbol. Click here, it will go to the token name. Token name, you can link back to the whatever, and then value to go straight to the value. When I go to the value, I must find same things like this. Number one, the code for that. That is number one. We need the code. Maybe we should number it so that when you get to singleton, your sections are numbered. Number one. And then the diagram, maybe you can say number two. Illustration of that function here. Here you use, it's a function. If it's a data type, you put the right diagram I have selected. Then number three, we need a tutorial on that, like this, beginner tutorial. This you get it from ChatGPT. Say, give me a beginner tutorial of, you copy and paste this. Then you copy it, then you come here, then you paste it. Did I leave out anything? I didn't leave out anything. That is how. Nice thing you don't save here. So when we click any of these, immediately it's a quick learning for you. It's a quick learning for you. So everything is here in this folder. So all what you will do, you will copy this folder, bring it to me. Copy it, supply me with this. So when I open yours here, it will have all your stuff, all your pictures that will be inside, everything will be inside. Don't delete anything here. Whether they are empty or they are what, you just leave it there. That is what you will give it to me. I will check it versus the module. I will just come here. If you are doing address, I'll click address. Then I'll go to source. Then I'll check the exported functions. These are these ones. Then I'll ignore this, ignore the comments. Then I'll go, data address. Then I'll check next one, pub key hash. Oh, this one is very short. Lucky you. Like that. That is all what I will check. Thank you very much. Let's call it a day for
Thank you,
today.
sir.
Thank you.
Thank you, sir.
All right.
Thank you, sir.
Thank you.